we are on camera now. All right, good. My first video that I hopefully will keep. How am I doing? Am I on?
Yeah.
Yeah, am I good? Okay.
Yeah.
So we're filming, yeah. My interior decorators here from New York. Excellent. Excellent. Okay. Further. Okay. So we have a bunch of words on the board, and I want to simply go through them, explain them. What's the chapter about? What's the name of this chapter?
Cycles in the biosphere.
Cycles in the biosphere. What's the biosphere?
It's like the whole, like the earth, the land, water,
Everything on earth.
It's really, yeah, well, the biosphere, it depends on what you're defining. It's the biggest. It's the most general. What's the problem?
20% battery remaining. It's not recording.
Thank you for, interrupting me, but that's not a problem. Can you focus, do you think? There you go. Excellent. Excellent. He's doing, I know, he's doing a battery check. That's okay. I like that. Okay. So we'll hook up the battery. Let me know when it's like 7%. So, the biosphere. So the biosphere includes what? Things like the land. What's the land called?
Earth.
What's it called?
Earth.
What's the land called?
Earth.
Little sphere.
The Earth is the big ball that hangs in space
Yeah.
with everything. Okay. So the lithosphere is the land. What's all the water?
Hydrosphere.
What is it? Hydrosphere? Is hydrosphere up here?
Yeah.
Yeah, here's hydrosphere.
Yeah.
Okay, so the hydrosphere is the water. Okay, and is it just the oceans?
Yeah.
No, not only in the river, sea, and even
Maybe
here.
so it's fresh water, right? Aquatic. Fresh water, not salty, is aquatic. What is the ocean? What would that be called? The what? The marine environment? The oceans, the marine environment, as opposed to the aquatic environment? Name me some lakes, some big lakes.
Big lake.
Yeah, in the world.
Big
Big lakes in the world.
River Nile.
The River Nile is a river. River Nile. We want lakes. Are you in the United, like in Canada? Where's some big lakes in Canada?
Oh, I know. What's the Hudson Bay.
Hudson Bay? Is Hudson Bay a lake?
No.
I don't think so.
It's a narrow.
Yeah, doesn't it open up to the ocean?
Yes.
Yeah. What about shall I say, you ready?
Lake Ontario.
Lake Ontario. What else? Lake Michigan, Lake Superior. These are lakes. Lake Erie.
Yeah.
Okay. They border between what two countries?
Ontario and.
Now, what two countries?
Country.
Canada. Good. And what's south of Canada?
The U.S.
The United States, right? Okay, excellent. Now, so we're going to talk about cycles in the biosphere. Name me a cycle in the biosphere.
Water cycle.
Water cycle. And describe to me what the water cycle is. You can look at your book. Describe to me what the water cycle is. Yes. Go ahead. Just describe it.
The water cycle is a process in which.
It's a process in which you sound like a textbook. That's a little scary. Go ahead.
The water and the resources.
The water. I'm not hearing you. The water. I have a air conditioning device in my ear. So it's say it again. Help me out if you hear what she's saying. Go ahead.
Like the water is under. Like the water of the lakes under. Lakes. Water evaporates.
Water evaporates. Excellent. From where?
From the river.
From where does water evaporate from? Lakes, rivers, the ocean. Okay.
From many places.
From many places. And okay, we have to look at what evaporation is in a moment, but it evaporates.
Yeah.
Okay. It goes from the liquid state to the gaseous state. And what does it do?
It forms clouds.
It forms clouds. Now, when water evaporates, what does it do? It rises, right? Now, is that relative to the land? Does that create low pressure or high pressure, and why? Why is it low pressure?
Because it's like.
The more low pressure, the thing goes higher.
All right, give me a piece of paper. Just a plain piece of paper. Anybody have any? Excellent. Okay, here's a piece of paper, right? Now, I'm going to reduce the pressure on this surface. You tell me what's happening when I reduce the pressure.
It goes up.
It rises, right? So when the air rises, it's not hitting the ground. It's not sitting on the ground. I'm talking about what's the pressure relative to the ground. So when it's bad weather or when things are evaporating greatly, when clouds are forming, the pressure is generally relative to the ground. The atmospheric pressure, the pressure pushing down on the land, is generally low or high?
Low.
It's low, okay, as opposed to high. What would high pressure be caused by?
High is like
High pressure will be like will be sitting on a flat ground, like
you can't
it's
pick it
got
up.
more gravity, stronger
More
gravity.
gravity.
Well, actually, high pressure is when you get, especially in Canada, you get these giant domes. For instance, let's say you take a pail. You take a pail of sand, and you put it on, it's open, it's a pail. You turn it upside down quickly, and you put it on a table. So you have this giant pail of sand sitting on the table, correct? All right, now, that sand is oxygen and nitrogen, say. That's what it represents, okay? It's sitting on the ground, okay? So here we have it here, okay? And we have this pail. And that pail is causing high pressure, correct? That sand is causing high pressure. That's the oxygen and nitrogen that makes up the air molecules, right? What happens if I take the pail, not the sand, I just take the pail away? What happens to the... It goes like this. And literally that's what happens. You get these giant domes of high pressure that simply cascade down and force bad weather out of the way. They are enormous systems that are made up of oxygen and nitrogen, and in North America, the weather goes from west to east generally, and you get these giant domes of cold oxygen and nitrogen, cold fresh air coming down from Canada, sweeping across the eastern United States and going out to sea. And any kind of bad weather is just swept away by this giant dome of high pressure. High pressure means because the air is descending. The air is descending. I take that pail away, I get this descending air. So it's hitting the ground. The pressure's high. When clouds are being formed, it's being formed by water being evaporated, and the water vapor is ascending. So you get this
Low pressure.
low pressure. Now, what happens to the clouds? Eventually, you're going to get what?
Sure. Most of the water goes up, like it becomes cloud, and as the cloud becomes heavier, so it gets more like when the pressure becomes low, so it gets rain.
Yeah, you get these cold winds through the clouds. The air loses as air rises, it loses about 10 degrees Celsius per kilometer it rises.
Yeah.
So you get these cold winds in the high altitudes, and it simply does what? It may even start out as snow or ice, and the rain from the water in the cloud comes down to earth. And what do you call that when you get this gaseous water turns to liquid or snow or ice and falls down to earth? What do you call that? When you go from a gas to a liquid, that's called what?
Oh, condensation.
That's called condensation. But when it happens in the clouds, when the clouds, in some cases very violently, go from gas to the liquid rain or snow or ice, what's that called?
Precipitation.
That's called precipitation. That's called, is it here? Precipitation. In chemistry, you may have heard the word precipitation. Have you ever, when things become undissolved in a solution, that's precipitation. I'll demonstrate that. That's a little bit heavy, but I will demonstrate what that means. What else do we have besides water in the water cycle? So the water's falling in terms of water, rain, snow, ice, something like that. And then what else? What else do you have in the water cycle? Is that it?
No, respiration.
No, well, is that the part of the water cycle?
No.
Well, we're talking about the water cycle. Look through the water cycle. Is there anything else?
No.
Anything else in the water cycle? Water evaporates.
Transpiration.
First, no, it's not.
Is that it?
Transpiration.
Water cycle? Let me just tell you something about the water cycle and hurricanes. You've heard about hurricanes in North America. We have typhoons, we have the monsoon here in Bangladesh. Why are they so violent? Why are they so violent? Typhoons, hurricanes, why are they so violent? Well, let's say I have a kilogram of water right here. I have a kilogram of iron here. A kilogram of water, liquid water. A kilogram of liquid water, a kilogram of iron. Okay? Which one has the capacity to contain more heat? The kilogram of water or the kilogram of iron? What do you think? Intuitively, which one do you think is going to be able to contain more? How many people say iron? Raise your hand. Yeah. Okay, iron. Okay. You got 3 for iron, 4 for iron. Okay. Okay, good. And how many people say water? The rest of you? Okay, so 4 we're split down the middle, right? Okay. Not only does water have the capacity to contain more heat energy, it has 10 times the capacity, almost 10 times the capacity to contain heat energy. Water can contain 10 times the amount of heat energy than the same mass of iron can. All right. So this, what would we call this particular film? Introduction and introduction in the water cycle.
Yeah.
Okay. So are we done with the water cycle? What else? Have you been reading? Do a little research there. I'll give you 30 seconds. What do you think? No? Carbon dioxide is in the water cycle?
No, the carbon dioxide and oxygen.
Carbon dioxide and oxygen are in the water cycle?
No, oxygen is.
I'm asking, what about the water cycle? Have we covered it? Do we have to talk about anything more?
Sir, transpiration.
We
Is
did
that in the water cycle? Did
Yes,
we do
it's in water
transpiration?
cycle. Sir, in transpiration, the water is taken from the plants.
Yeah, in transpiration, okay, here we have a plant. Can we see down here? Let's go over here. Here we have the soil, okay, and then we have a plant. Make a very simple plant, okay. That's the plant, leaves, okay. What happens is you get this root system in the plant, this root system, and the root is in the soil, and in the soil there's what? Water, and what else? Minerals, nutrients, fertilizer, whatever it is. Okay. So the water is literally sucked up by the plant. And then what happens to the water when it goes to the plant?
It's distributed to all the parts.
It goes to all the parts of the plant, and then does it leave the plant, or just the plant gets bigger and bigger and fatter with water and it never leaves? Or what happens? That's a hint. It grows, but what happens to the water? What's the process of transpiration? What's the process?
The water evaporates.
It evaporates, but where does it evaporate from?
The water
We did this, right?
The water is inside of the plant.
It literally goes, it's a cycle. Here's the roots, right? Let's say here's a leaf, right? Big leaf. It goes up through the stem to the leaf, and there's little holes in the leaf. If you look at it through a microscope, you can see these little cells, called guard cells. And it has little pores, and it evaporates through the leaf into the air. So it's sucked up here in the roots, and it goes through the cells out into the air. It's transpiration. Water is sucked up here and goes up through the leaf. Now, in desert communities like in United Arab Emirates and in Saudi Arabia, where it's desert, they plant enormous numbers of trees. Now, there's an aquifer underneath the desert. There are aquifers. And what's happening is this. They're planting so many trees that shouldn't be there, that aquifer is being depleted. And the land in some areas in the desert is actually collapsing. It's shrinking. The land's going down. Because you have this giant aquifer. You have this giant aquifer here. Here's the land. Okay? Can you see this on the film?
Yeah.
Here's the aquifer here. That's the water. You have the plants are taking water out, and the land is simply, it's not coming out? Okay. So let me do this. Let me erase this. So here's the land, right? That's the aquifer. The aquifer of the water, okay, that's underneath the desert. And you're sucking it out through planting trees, big plants and trees. And this is shrinking, and the desert floor is falling. The desert doesn't get a lot of rain. This aquifer is built up over many, 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 many years. And you get these giant trees that literally suck out gallons upon gallons upon gallons upon kilograms of water. 1 cubic meter, we're going to talk about this in a minute. 1 cubic meter of water, meter tall, like this, meter. 1 cubic meter of water weighs 1 metric ton, 2,200 pounds, 1,000 kilograms. 1 metric ton is 1,000 kilograms. 1 cubic meter of water weighs 1 metric ton. So what's going to take its place? Well, it's just simply going to fall. Yes? You get it?